All right, so today we're going to have some fun. Today, we can truly say we are doing full on, beginning to end, stoichiometry. It's just too fun of a word to say to not, you know, actually make a video about it. So, full on stoichiometry, really what it's used for is when we did our moles to moles conversion, that kind of got us started. Really, it allows us to predict amounts of reactants or products needed if we kind of know some of the other products and reactants, okay? So we did add some things to our converting flow chart here. So really though, once we find moles of Y, we can find the mass of whatever our Y substance is by taking our moles times molar mass, which is in grams from the periodic table. Or if we have moles, we can also find from the units. You know, if I have, take that moles times 6.02 times 10 to the 23rd. And once again, typically we're never going to have to go backwards from this. And if we're only working with one substance, we're really only going to just use the top there. All right, so very, very common equation is 2 moles of hydrogen plus 1 mole of O2 becomes 2 moles of H2O. This would be like a hydrogen fuel cell with the chemical reaction for that would use to power cars, stuff like that. And let's say that we have 13 grams of H2. And if we're going to start off kind of easy, let's just predict how many moles of H2O we should produce, okay? So here, H2, that's what I'm given. That's my X, so let's put a little X above it. H2O is what I'm looking for. That's my Y. All right, one of the first steps we need to do is figure out of these top three, which one am I starting with? So in this case, I'm starting with 13 grams. Grams is a measure of mass of X. So I'm starting right here. And I'm looking for moles of H2O, or I'm looking for the moles of another substance, that'd be Y. I'm going to end right here. So I need to go from here over to here, down to here. So here's how that's going to look. So I'll just write down what we know. We know 13 grams of H2. You're going to need a periodic table for this, okay? So from here, I'm going to follow the arrow going to moles of X. It looks like I'm going to have 1 mole of that substance, so 1 mole of H2 on top, and that's over the molar mass of H2. So if you check your periodic table, one hydrogen has a mass of 1, so 2 hydrogens would have a molar mass of 2 grams. Right, so even if I'm doing my unit conversion as I go, grams of H2 on top, grams of H2 on the bottom. That gets me here. So now I need to do this jump here. So I'm going to have another conversion. According to that, moles of X are moles of starting substance on the bottom. Go to the go to the chemical equation, sorry. Looks like I have 2 moles of H2, so that goes on the bottom. And then moles of what I'm looking for Y. Okay, and there's 2 moles of H2O there. So now moles of H2 on top, moles of H2 on the bottom. Those cancel out. So now according to my math, I'm left with moles of H2O, and that's what my problem's asking for. So in this case, 13 divided by 2 times 2 will give me the same answer either way. That'll be 6.5 moles of H2O. All right, so that's kind of the answer to that. Essentially, it's where are you starting? Follow the arrows. Where are you ending? Okay. So let me go ahead and erase that, and let's try one that's a tiny bit trickier. And let me make that bigger just for this part. Try not to erase my original equation. Oh, looks like I was going too fast. Uh-oh, having some mouse issues. Good enough. All right. So, same equation. We need to erase the x and y. X gone, y is gone. All right. This time, let's say that we have, let's go with 8 times 10 to the 24th molecules of O2. And let's say that we want to go to what mass of H2 will be needed to do that. All right, so in this case, let's figure out our x and y. So in this case, I'm starting with O2. That's my x. I'm looking for the mass of H2. That's my y. All right, so I'm starting with 8 times 10 to the 24th molecules of a substance. So molecules, remember, are a form of formula units. So I'm going to start here. Put a star next to it this time. And I'm looking for the mass of a different substance. So in this case, I'm looking for the mass of y. I need to end here. So in this case, I need to go from formula units to moles of x, from moles of x to moles of y, and then the kicker, moles of y to mass of y. All right, so first step, write down what you know. Keep in mind, I try to keep my scientific notation things in parentheses. So 8 times 10 to the 24th molecules of O2 times, so to go from here to here, following that arrow, 1 mole of that substance goes on top. And then 6.02 times 10 to the 23rd goes on the bottom. Keep in mind, molecules are formula units. Kind of surprised I fit that in there. All right. Next conversions to go from moles of x to moles of y. Come down here, moles of O2. That's my x. That's going on the bottom. Reaction, there's one of those, so 1 mole O2 on the bottom. What I'm looking for is 2 moles, so 2 moles of H2 goes on top. And that gets me to here, so now I need to go from here to here. It looks like this arrow is 1 mole of the substance on the bottom. And the mass of it goes on top. Once again, the mass of H2, molar mass of H2 is 2 grams. All right, so let's check my units to make sure I did it right. Molecules O2 on top, molecules O2 on the bottom. Those cancel. Moles O2 on top, moles O2 on the bottom. Cancel. Moles of H2 on top, moles of H2 on the bottom. I'm left with grams of H2, which is what my question's asking for, so I at least know I did that part right. So let's see if I can do the next tricky part, which is typing it into the calculator correctly. All right, so we have parentheses 8 times 10 raised to the 24th power. Divide by numbers at the bottom, so divided by parentheses 6.02 times 10 to the 23rd, closing parentheses. Next one is times 2, divided by 1, and then times 2 again. And it looks like we should end up producing 53, bring that back up, 0.16, 53.16 grams of H2. And really when I'm looking at it, here I can see I have over 10 moles of O2, so just kind of guesstimating, I would need at least 20 moles, a little, just about 20 moles of H2. 20 times 2 is roughly 40. So that's, pretty close. Good enough answer anyway. That's pretty much how you do stoichiometry. It's just, with that flowchart, it's just figuring out where are you starting, where are you ending. With that, good luck with the practice and have fun.